Today's preparation is about rate of return and incremental analysis. So up until now, we've decided, I've given you an interest rate to use for every problem. And the question might be, where do these come from? It's typically not obvious. It's not always that there is a bank involved that can provide that interest rate. For individuals, yeah, it's often the what a bank can provide as the interest rate. Whatever they can earn in a relatively risk-free environment. You put your money into the bank, it's pretty much guaranteed to give you back that interest rate that they specify. So when you're talking about individuals, yes, banks are often where they get their rate of return or their interest rate to use in economic analysis. But for businesses, they need to decide on the interest rate that they're going to use, and that's usually the minimum attractive rate of return to the company. It's the minimum attractive rate of return is exactly what it says. Whatever the minimum amount is that they're willing to get back on their limited resources and that's based on their actual rate of return that they've realized in past investments. So let's take an example here. You have a pickle slicer that you could buy. The initial cost is $57K, and because the additional profits for your company in these years 1 through 5 and nothing after that, you're considering investing in it. Your company has access to a bank account that earns 10% interest. Over the past 10 years, your company's average rate of return on its investments has been 20%. And the owner has specified that the minimum attractive rate of return is 15%. So we are trying to decide whether this is an attractive investment or not. And this hints at, even though we have access to a bank account that earns 10% interest and our average rate of return has been 20%, we're asking whether or not this is a good idea, whether this is an attractive investment to the company. And if the minimum attractive rate of return is 15%, as long as we're getting beyond that minimum attractive rate of return, this would be attractive. In this case, this is the appropriate interest rate to use in the problem, the minimum attractive rate of return, if we're trying to determine whether it's an attractive investment or not. So let's do this problem, and let's use that minimum attractive rate of return. Oh, so I think actually we're going to do this one in Excel. Here's time. Here is the cash flow. I'm just going to enter the total cash flow. We've got time 0, 1, up through year 5. And our cash flows in those years, negative 57 to begin with, 7.5, 7.8, 8.6, 9.8, and 13.2. We're going to specify an interest rate in the problem. I'm going to use the minimum attractive rate of return. I'm going to define the discount factor, which we've done many times before, 1 plus the interest rate to the negative. Remember that negative sign, year. I've seen a lot of labs and such where people didn't use the negative there. Also, we need to make sure that we fix B2 to be this cell. So even when we're down here, we haven't moved down to using cash flow as our interest rate. All right, that's our discount factor. The present value of each of these is the product of the cash flow and the discount factor. And we sum them all to get the NPV. And we find that the NPV in this case is negative. And because it's negative, that means that this is not an attractive investment. Okay. If it were positive, it would be attractive. If it were 0, then it would be realizing the same rate of return that we normally we consider to be attractive. So how do we define rate of return? Intuitively, it's the effective annual interest rate at which an investment accrues income. In the preparation document, I gave you an example definition. You could say, all right, well, here's the return that I got after 1 year. I'm going to divide that by the amount that I put in the last year, and that's my effective rate of return, right? But how do you deal with that? in practice, when you've got more complicated cash flows, it's the effective annual interest rate that makes the net present value 0. And note that this jibes really well with what we said with the minimum attractive rate of return. If the net present value is positive, using the minimum attractive rate of return as the interest rate, then we consider it attractive. If the net present value is negative, considering the minimum attractive rate of return as the interest rate, then it's not attractive. And if the net present value is 0, using the minimum attractive rate of return as the interest rate, then it's just borderline attractive to us. And so how do you define the rate of return that it is realized on a given investment? It's the one that makes the net present value 0. That all kind of fits together. Okay, so here's another example. How do we calculate the rate of return for a particular problem? A project that has an initial cost of $100,000 is going to return $17,000 per year for 10 years. What is the rate of return? We're trying to find the rate of return. And you do that. This is the interest rate that you could use in this problem when doing NPV analysis that makes the NPV 0. So let's calculate the NPV assuming we know what the interest rate is. Let's say we've got an interest rate I. So the NPV is, well, we've got a present cost, P is equal to $100,000, plus we have, it's negative initially, we'll take that into account, $17,000 per year for 10 years. So we've got an annuity, 17. So this is negative 100. This here is 17. And then we have a discount factor. This is the one that converts between an A and a P at whatever our interest rate is, but we know that N is equal to 10 years. And we say, in order to find the interest rate, we're going to set this equal to 0. So let's treat this as a variable and we'll just do some algebra, right? Because P is known, A is known, this is unknown because we don't know the interest rate, and we've got a 0 on the right hand side, so that's known. So let's go ahead and rearrange this problem. We've got A, P over A, I, N equals 10 is equal to, add P to both sides, is equal to P. Or we could also say that P over A, I, N is equal to 10. That thing is equal to whatever the P is in our problem and the A is in our problem, is equal to 100 divided by, this is negative P, right? Because we subtracted it from both sides. So this is negative P over A. That's the negative of negative 100. So that's positive 100 divided by 17. And 100 divided by 17 is 5.88. Okay. What does that do for us? P over A, for whatever the interest rate is, for N equals 10 years, is 5.88. That means we can look in the interest rate. We actually kind of did this sort of problem before where we were given P, we were given A, we had to find the interest rate. We just need to look in the interest rate tables and find which table has P over A at 10 years being 5.88. P over A at 10 years needs to be 5.88. So the interest rate is not 0.5. It's not 1.0. It's not 1.5. This is not 5.88. This is not 5.88, but we appear to be getting closer. Also not 5.88. Still not there. Still not there. 6.1146. We're getting closer to 5.88. And 5.6502. So it's somewhere in between here, this interest rate table, and this interest rate table. It's actually about halfway in between 10% and 12%. So we'll say that the interest rate in this problem is around 11%. And what you could do is you could use the formula for whatever this P over A factor is. So I suppose if we wanted to do this more precisely, we could use the formula for P over A. 2P given A. We could use this 1 plus I to the n minus 1, right? I could substitute that formula on this side and solve for I. Right, we could potentially do that. That could be quite difficult to do. Maybe our best bet is to guess and check. Guess a number that's a little higher than 11%, guess a number that's a little lower, and then just keep on zeroing in on what the answer is. But on the FE exam, it's going to be a multiple choice, right? So basically, if it asks you to calculate what the interest rate is for a given investment, then you can just plug in all the answers and see which one gives you a net present value of 0. That's typically how that would work. So you just have to get close. They know that you are not a computer and won't have Excel with you. Now, if you do have Excel, let's do a problem that really would require Excel. So this pickle slicer from that past example, it had a negative rate of return, had a negative net present value. Let's find out what the rate of return is. So same thing. It doesn't matter. These don't matter anymore. We don't care about what access to the bank account, etc. What is the rate of return for this machine? It's the interest rate that would make the net present value 0. So we're going to assume a certain interest rate. Maybe I'll assume it's 15% to begin with. I'll calculate the net present value again. I'll use my spreadsheet, but I'm going to keep on adjusting that interest rate until I get a net present value of 0. Right, so here's our spreadsheet from before. Let's see what happens if I use 20%. No, that makes it even more negative. 10%, 5%, 0%. Oh boy, negative 5%. We're getting closer. Negative 7%. Okay, that just went from negative to positive. So negative 5. How about negative 6? Something close to negative 6. Now, we can use the computer to automatically do this iteration for us. If you go to the Data menu and What If Analysis and click on Goal Seek, some of you might be familiar with this. What we want to do is set the cell, this NPV cell, to what value? 0. What cell do we change in order to do it? Change this one. We say OK. And it solves for us. It ends up finding, let's increase the number of decimal places, negative 5.66% is the interest rate that makes the net present value 0. So the effective rate of return on the investment is negative 5.66%. So the rate of return, again, how do you calculate that? It is the interest rate that you would use in a problem such that if you were calculating the net present value, you'd get a 0 net present value. And so what you can do is you can do it algebraically in simple cases, or you can create a spreadsheet, assume a certain interest rate, and then keep on adjusting that interest rate until you make the net present value 0, and that will tell you what the rate of return is. So I want to take just a second to provide an interpretation of net present value, and I think this fits in with the rest of the things we've been talking about, and hopefully will bring some things together. If it doesn't bring things together for you and confuses you a little bit more, it might just take a little bit additional time and practice with these things to make it all gel in your head. I think that you've got the information, you can do the problems, but the intuition is still developing, and that's okay. But here's what I wanted to say about this if we want to make an interpretation of net present value, and I'll do an example. You've got an investment opportunity, and you're going to analyze it for what its net present value is, assuming a certain interest rate. If you had a bank account with that interest rate, and you placed whatever that net present value was, and you placed any disbursements, anything you would have given to the investment, you instead put in this bank account that earns whatever the interest rate is, From the bank account, you can also take out any receipts that you would have received if you had put them instead into the investment. So we're considering two alternatives. We're placing our money in the investment, or we're placing our money into this bank account. In addition, we place this NPV at the very beginning. If you did this, then the bank account is going to be empty at the end of the investment period. And it basically tells you that if you had this additional NPV and you put it into the bank account with whatever interest rate you're using for the problem, it earns that percent interest, then the bank account is equivalent to the investment opportunity. So let's see how this works. Let's do an example with this and see that this is indeed the case. And hopefully that gives you some additional intuition about what net present value means. So we have a project that has an initial cost of $100,000 and it will return $17K per year for the next 10 years. This is the same as one of the earlier examples. Let's now assume that the interest rate is 5%. What's the net present value? Okay, so nothing new here. We're just asking what the net present value is for this problem. Let's calculate that here in Excel. We'll make it easier on ourselves. Okay, so we have time for this problem, time 0, 1, 10 years. And we have costs or cash flows, and we start out with negative 100, and we start taking out 17 per year for the next 10 years. Let's define, we can actually just copy this discount factor over. Yep, still works. And here's what the discount factor is. Oh yeah, the discount factor is greater than 1 because we have a negative rate of return. But let's change this over to 5%, right? Positive 5%. There we go. More normal discount factors. And then our present value of each of these is the product of the cash flow and the discount factor. And we can take the net present value. But I think we're going to have to adjust this. We have to increase what it sums over. All right, the net present value is 31.26. That's the net present value of this investment with an interest rate of 5%. Okay, and then we said, suppose we placed into a bank account that earns 5% interest. First, we place the net present value from the previous problem. So we place $31,000 into it and an additional $100,000 because that is what we initially placed into this investment. So we're going to place the NPV and then this amount, $100, into the bank account. So let's model the bank account's balance over time. We're going to need columns that talk about how much interest was earned on the account. We're going to put any contributions, any credits to the bank account. So any additions, any debits or amounts that we take out, and we're going to have the account balance at the end of the year. And we're going to have for this certain period of time. So we're going to use the same years column. So we start out, and previously the bank account wasn't open. So over the last year, we didn't earn any interest on it. We credit it initially. We add to it $100. Because that's what we put into this investment initially. We're saying it's positive because it's a credit to the bank account, but it's whatever we put into the investment. We actually also put in the net present value. We don't take anything out of it immediately. And so at this time, the balance on the bank account at the beginning of year 0 is the sum of all these things. Now, how much interest do we earn over the course of the first year before we get to the end of year 1? We earn whatever the interest rate is times whatever the balance was on the account. We say at the end of the year, we take a look at the account balance from the previous time, and we say that is the amount of interest that we're going to earn. Yeah, there we go. We credit the bank account nothing, but we debit from it, we take out 17. Let's make sure I'm calculating. It's not the sum of all these actually. I'm gonna say we're gonna get whatever the interest was plus the credit minus what we're taking out of the account. That's what the account balance is. All right, so we earned whatever the interest rate is times the previous account balance in interest. We didn't add any more to the account. We did take out 17 from the account. So our new account balance at the end of this year is whatever the previous account balance was plus whatever interest we earned plus whatever credit we got minus whatever we debited from it. And we're going to continue this process. We're going to keep on taking out 17 per year. We're going to keep on earning interest on whatever the previous amount was. We're going to keep on not removing anything. I should double check this interest formula. I need to make sure that I lock B2. That's the story of my life. Lock that interest rate. And then I'm going to see what the account balance is from year to year. So it calculates the interest rate based on the previous account balance and keeps on taking out 17 in addition. You end up with $0 in the bank account at the end of this time. So that is what I was getting at with this slide, is that if you have this investment opportunity and you were to analyze what its NPV is, this investment opportunity, we found out that the NPV was 31.269 with an interest rate of 5%. And we had a bank account and we said it's going to earn this 5% interest. And into that bank account, we put the net present value. We put any disbursements, this negative 100 that we would have put into the investment. Instead, we put it into this bank account. And from the bank account, we remove anything that we received. So we received 17K per year from the investment. So we take it out of the bank account and we do the simulation of the bank account accruing interest based on the previous balance. At the end of the 10 years, we have $0 left in the bank account. So that's a little bit more intuition about what it means for a net present value. It's a comparison between a net present value of 0 doesn't mean it's a bad thing. It just means it's not any more attractive than what else you could be doing with your money. It's not any more attractive than a bank account with the interest rate that you used in the problem. So let's talk about comparison of alternatives. That's a technical term in engineering economics, but we've already been doing it. This means when you've got two different things or three different things, any number of mutually exclusive investment options that compete for a limited amount of money. It means that you need to choose between option A, B, and C. You cannot do both of them, say, or two of them. You can't do all three. You can only pick one. And this happens a lot. So there's one way of doing it is you use present worth analysis. We didn't call it that, but you just compare the NPVs of the two or the three options, and you pick the one with the highest NPV. This is only something that you can do if your investment opportunities have the same lives. We talked about that before. That brought up the idea of the equivalent uniform annual cost. And so annual cost analysis is when you compare the EUACs and you want to get the one with the lower equivalent uniform annual cost. So we wanted to increase the benefit, we want the higher benefit, we want the lower cost. Assume each alternative is renewed indefinitely, and that's how we get away with it, right? Is, yeah, sure, the options might have different lives, but they are going to be repeated indefinitely. And the same sort of thing with capitalized cost, and we can compare the capitalized costs. Rate of return analysis is a little bit different. You cannot simply compare rates of return. You need to use a process called incremental analysis. And there was an example in the preparation document that says why this is the case, and I think that you'll see that here. So here's the example we're going to do. Suppose that our interest rate, our minimum attractive rate of return is 15%, and you've got two investment options. You can invest $1,000 today and receive $1,200 at the end of the year. Or you've got option B, which is investing $2,000 today and receiving $2,350 at the end of the year. And so which is the more attractive option? Let's go ahead and solve that. And we're going to solve that, let's start with NPV, right? Well, let's first think about it for a second. This one here, they're both just 1 year investments. So it's very simple to calculate the rate of return here. This one is you're getting an additional 200 after 1 year. It looks like we've earned 20% on our $1,000, right? So that's the rate of return on this one. This one here, we put in 2,000. If it were a 20% rate of return, we'd expect to have gotten $4,000. So this is not a 20% rate of return, it's less than that. So this one has the lower rate of return. This one has a 20%, this one's lower than that. What is that? What is 350 divided by 2,000? 350 divided by 2,000 is 17.5% rate of return. But which is more attractive? So we say that we should be able to use net present value to do that. So let's go ahead and calculate the net present values of the two. So option A is P is equal to, NPV of A is this negative 1,000 plus whatever the conversion factor is to get P from F. We've got a 15% minimum attractive rate of return, and we have just a 1 year period. So actually, I know what this is, right? I know that after 1 year, the future amount is whatever the present amount is times 1 plus I. And so for 1 year, my P over F factor has got to be 1 over 1 plus I. So this gets multiplied by our future amount. I'll write this symbolically first, is whatever the present value plus F times P over F. Okay. This here, that is that. 1 over 1 plus I. This F here is 1,200, and this P here is negative 1,000. Okay. Let's do it. Negative 1,000 plus 1,200 over 1 plus 0.15. Calculate it out, and we get 43.47. And the net present value of the second option is equal to present amount, so 2,000, with the same kinds of cash flows, plus 2350 all over 1.15. If you calculate this out, negative 2,000 plus 2350 divided by 1.15, you get the same thing, 43.47. And so this shows that if we believe net present value is a good idea, and I think we've got good evidence for that, then even though these things have a different rate of return, and actually the rate of return for option B is lower than the rate of return for option A, they still have the same net present value. And so these two options are equivalent to one another. So how could we determine that if we wanted to use rate of return? You do what's called incremental analysis. So we first rank the two alternatives in order of increasing initial investment. So in our case, A requires a lower initial investment, and B is a higher one, and we rank it in order. So option A is lower, and then B is higher. We calculate the difference in cash flows by year. So we take a look at alternative B minus alternative A. So we calculate the difference in cash flow. Let's actually do this step by step. We'll keep on switching back and forth. Okay, so option B was higher, so we say we're going to take the difference in cash flows each year. So here's our present cash flows, and here's our future at n equals 1 year cash flow. We need to subtract from year to year. So we've got option B, and we've got option A. B, the present cash flow was negative 2,000, and we subtract the negative 1,000 And so we're going to get the difference between them, I'll call it delta, is equal to negative 1,000. And then the future payments after 1 year, well, B is going to get 2350 back. And we subtract 1,200 is the future for option A. So our delta here is 1,150. Calculate the difference in cash flows year by year. Done. So this is a fictitious third alternative, B minus A. I've called it delta. Calculate the rate of return of the alternative B minus A. So what's the rate of return of this investment here? All right. Well, we calculate the NPV is equal to negative 1,000, which is the first year of this one, plus 1150 times whatever the discount factor is, P given F, whatever the interest rate is. We're trying to calculate the rate of return. We don't know what it is. N is equal to 1 year. But we know what this factor looks like, right? It's 1 over 1 plus I. Okay, so I'm going to replace that with 1 plus I. And we set this equal to 0. We need to solve for what I is. So this is the algebraic way of getting the rate of return. So we know that 1150 is equal to positive 1,000 times a factor of 1 plus I. And I think you can see where this is going from here. If I were 15%, then 1 plus I is 1.15. Then this 1,000 would turn into 1150. And so I in this problem is 15%. Okay, so I is equal to 15%. What's the next part? We say the additional investment required by B is only warranted if the rate of return of the B minus A, or delta, is greater than the minimum attractive rate of return. If not, invest in A and find a better use for the remaining money. So this incremental analysis allows us to use rate of return to choose between the two investments. We can't directly compare the rates of return of each of the investments separately to choose between them. You've seen that it's not going to give us the right answer. But we can use the rate of return on this incremental investment, this delta or B minus A, to choose between the two investments. So in our case, the rate of return of the incremental investment, delta, 15%, is exactly equal to the minimum attractive rate of return. And that means that the two investments are equivalent for the given interest rate. There's no preference. We already knew about that because the NPVs were equal. Now, if the rate of return on delta were greater than the minimum attractive rate of return, then the larger investment, B, would be justified. On the other hand, if the rate of return on delta were less than the minimum attractive rate of return, the larger investment, B, would not be justified. We'd invest in A and invest in the leftover money somewhere else.